Today, we're diving into an attack pattern called ShadowMQ. So what exactly is ShadowMQ? Well, it's a vulnerability pattern that targets AI inference servers. And the whole issue comes down to a really dangerous combination, the unsafe use of Python's Pickle deserialization happening over unauthenticated ZeroMQ network sockets. It's a recipe for trouble. So where did this thing first pop up? The first time we saw this in the wild was back in 2024 inside Meta's Llama stack. Okay, let's get into the technical weeds for a second. The problem lies in this interaction between two key pieces. On one hand, you've got ZeroMQ's receive PyObj function, which is designed to, just receive Python objects over the network. But here's the kicker. It uses Python's pickle.loads to do its job. And if you know anything about Pickle, you know it's not safe with untrusted data. It can literally execute arbitrary code. So if you were an attacker, how would you pull this off? It's a pretty straightforward 5-step process. First, you'd find an exposed ZeroMQ TCP socket out on the internet. Then, you'd craft a special, malicious Python object and serialize it. Step 3, you just send that payload over to the socket you found. The server, on the other end, dutifully uses receive_POBJ, which then uses Pickle to deserialize your object. And boom, step 5, your embedded code runs right on their server. So what did Meta do about it? Well, they patched the Llama stack, and this vulnerability got its own identifier, CVE-2024-50050. The fix was pretty logical. They just ripped out the insecure Pickle part and replaced it with a much safer JSON-based serialization mechanism. But this wasn't just a one-off problem with Meta. This thing had legs. The same flaw started showing up all over the place. And when I say all over, I mean it. The exact same vulnerability pattern was found in a bunch of other major AI frameworks. We're talking NVIDIA's TensorRT LLM, vLLM, SGLang, and even the modular Max server. So how did this happen? How did the same flaw spread so far and wide? The answer is something really common in open source: direct code reuse. Developers were literally just copying and pasting the vulnerable files from one project and adapting them for another. And we don't even have to guess. There's a smoking gun. In a vulnerable file in the SGLang project, there's a header comment that says it all, plain as day, adapted from vLLM. This created a kind of chain reaction of inherited risk. For example, Modular's Max server ended up pulling in logic from both vLLM and SGLang, meaning it inherited the vulnerability from both of them. Okay, so we know how it spread, but what does this actually mean in terms of real-world risk? Let's take a look at the impact. The scale of exposure was significant. Scans of the public internet that were looking for that unique ZeroMQ handshake banner turned up thousands of exposed, unencrypted sockets, just sitting there, wide open. And if an attacker gets in, they can do some serious damage. We're talking about running any code they want on the server cluster, escalating their privileges to move deeper into the internal network, and stealing sensitive data, including the AI models themselves and any secrets. They could even install GPU-based crypto miners to use the hardware for their own profit. So once this was all discovered, how did the different projects respond? Let's walk through the disclosure and patching timeline. Meta was first, patching the Llama stack back in October 2024. Then, a wave of fixes came in mid-2025. vLLM and NVIDIA both pushed out patches for their frameworks in May, and Modular followed suit, patching its Max server in June 2025. So who's in the clear? Well, Meta, NVIDIA, vLLM, and Modular have all released patches. But the story isn't over. Microsoft's Acerith Surf framework is still unpatched, and while SGLang did implement a fix, it's considered to be incomplete. It really makes you think, doesn't it? In a world of rapid innovation where high-performance code gets copied and reused across an entire ecosystem, how can security auditing possibly keep up?